Hi, welcome to Wise Guys. This video is on finding trig functions. Okay, so here we have our x and y axis, and we have a line drawn up here. We're told that the terminal side passes through the point 12 and 5. So this point here then is 12 and 5. So we know that the 12 is the x, so that's this length here, which is our 12. And the y is the 5, so then this side here is our 5. So this is our right angle triangle right here. Now what we need to do is solve for r, and we use Pythagoras. So a squared plus b squared equals c squared. And we're looking for our hypotenuse. So in this case, r then equals the square root of a squared plus b squared. So the 12 squared plus the 5 squared. And when we do that math, we end up with the square root of 144 plus 25, which is the square root of 169. And we end up with r equaling 13. So here we have 12, here we have 5, and at this point we have 13. So now when we're wanting to find the cos of the angle is the adjacent over the hypotenuse, and sometimes it's helpful just to write it out for yourself so you can see it. It's less thinking, right? And our adjacent side, so adjacent to theta, because this is the cos of theta, so adjacent to theta is our 12. And our hypotenuse is the 13. And we're leaving it as 12 over 13 because the question has asked for the answer to be an exact form. If we did the division here, we'd have an answer that's not an exact form. Now the tan of theta is opposite over adjacent. So the side that's opposite the angle is the 5. And the side that's adjacent the angle is the 12. And again, this would be just left as 5 over 12 because that's an exact answer. And let's just talk about what that means. If we take the 5 and divide it by the 12, we end up with 0.41666666, which is not considered exact. So that's why we just leave it as a fractional answer. Now the secant of the angle is 1 over the cos of the angle. All right? So we know the cos of the angle is 12 over 13, so that means this is 1 over 12 over 13. Here what we have is the division of two fractions, essentially. This is essentially 1 over 1 divided by 12 over 13, which ends up being 1 over 1 times 13 over 12, which is 13 over 12. So basically it's just the flip of this, all right? So that's the secant, 13 over 12. Now the cosecant is 1 over the sine of theta. We didn't solve for the sine of the theta, but we know the sine of theta is opposite over hypotenuse. So the cosecant must be the inverse of that. It must be the hypotenuse over opposite. All right? So again, the sine is opposite over hypotenuse. So the cosecant has to be the inverse of that. The hypotenuse is 13, and the opposite is 5. So then the cosecant of the angle is 13 over 5. The cotangent of the angle is 1 over the tan of the angle. The tan of the angle was 5 over 12. So then this is 1 over 5 over 12. Again, we have the division of two fractions here. So this is 1 divided by 1 over, 1 over 1 divided by 5 over 12. So that becomes 1 over 1 times 12 over 5, which is 12 over 5. And you can see what happens is the tan of the angle is 5 over 12. The cotangent of the angle is just the flip of that. It's just 12 over 5. Okay, last question. So A is 7.3, B is 4.1. So this is 7.3, 4.1. We need to find the hypotenuse. So that would be C equals the square root of 7.3 squared plus 4.1 squared, which equals 7.3, oh yeah, right, different calculator. Yeah, okay. 7.3 squared plus 4.1 squared equals, and that's 70.1. .4. So our hypotenuse is 8.4. So that's what we have here. So now we want the sine of theta. So the sine of the theta is the opposite side over the hypotenuse. So here's theta. So the side that's opposite is the 4.1. So this is the 4.1 then over the hypotenuse, which is 8.4. 4.1 divided by 8.4 equals. Does that make sense? Let me think. Yeah, okay. So 0.4, let's go with 0.49. So 0.49. Excuse me. The tan of the angle is opposite over adjacent, and that's the tan of theta. So with regards to theta, the opposite is the 4.1, and the adjacent is the 7.3. So then we end up with 4.1 divided by 7.3. We end up with 0.56. And we have 2 sig figs to start here, so that's why we're sticking with 2 sig figs here. Excuse me. The cos of alpha. So now we're talking about this angle. So the cos of alpha. And when we look at this, we can see that the side, so let's just talk about cos. Cos is adjacent over hypotenuse. So the side that's adjacent, alpha, is 4.1. And the hypotenuse, again, is 8.4. So you can see that the cos of alpha is the same as the sine of theta, okay? Which, I mean, is going to happen, right? So 4.1 divided by 8.4, we end up again with 0.49. The cotangent of alpha is 1 over the tan of alpha. So we have 1 over, and the tan of alpha, where are we here? There's alpha. So the tan of alpha is opposite over adjacent. All right? So the opposite of alpha over the adjacent to alpha. So that means it's 7.3 divided by 4.1. Again, we have the division of two fractions here, so the bottom one flips. We end up with 4.1 over 7.3, which we did up here, and that is 0.56. Now notice that the tan of theta was 0.56 and the cotangent of alpha. So these two are inverse of one another, of course, and we end up with the same answers. The secant of theta is 1 over the cos of theta. And of course this is reasonable. We should end up with the same. The tan of theta should be the cotangent of alpha. So 1 over the cos of theta, which we didn't do, right? So 1 over the cos of theta, right here, is, my computer just went asleep. I had to turn it back on. So the cos of theta, yeah, let's just do it that way. Adjacent over hypotenuse. So 1 over the adjacent to theta is 7.3. And the hypotenuse is 8.4. So basically, again, division of two fractions. So this bottom one flips, and we end up with 8.4 divided by 7.3. And 8.4 divided by 7.3 equals 1.2. So 1.2. All right. So that's just, again, a sort of a quick run through trig functions. And that was brought to you by Wise Guys. I hope you have a super day. Take care.